Good evening, everyone. Thank you for joining us for the second of 3 webinars this winter for Pioneer customers in North Dakota, South Dakota, and Minnesota. Tonight, Dr. Adam Gaspar is going to speak about driving high soybean yields and profit potential. You'll hear about management strategies that can help boost yields on your farm. Adam joined Pioneer in 2016 after completing his master's and PhD degrees in agronomy and plant physiology at the University of Wisconsin-Madison. After serving as a field agronomist in Illinois, Adam was named a field scientist with the Integrated Field Sciences team at Corteva Agriscience. Adam is highly regarded for his expertise in soybean physiology and management. Adam's got a great presentation prepared tonight, and with that, I'll turn it over to Adam.
Well, thank you very much, Wade, and good evening, everybody. I'm happy to be able to join the group here on the phone. I'm sitting over here in Wisconsin right now, and we probably have a little bit more snow than you guys do in South Dakota, Minnesota, the Dakota region. I'm really excited about this opportunity, and just to kick it off, I'd encourage everybody to please ask questions through the chat panel as we're walking through this presentation. It's certainly always easier to answer them as we're going over different topics. As Wade said, graduated from UW-Madison, but actually my family and I and my wife, we farm in Lake County, South Dakota, so very familiar with the area that many of the growers are from on this call. And besides having a pretty good perspective on the local soybean production situation out west, I do a lot of work all over the country for soybeans, so it's allowed me to bring some nice perspective, and I hope to be able to share some of that with all of you on soybean production. A little bit of a breakdown of how we're going to go through tonight, just so you're maybe can prepare some questions and be ready. We're going to first talk about just current soybean yield trends and ask the question, is corn still king? Then on to different soybean management practices that we can exploit the physiology of the plant and also increase production and profitability. Recently, Pioneer just released a soybean variable rate seeding tool that we're going to cover, first of its kind in the industry, and then move on to some fertility tidbits and some other management practices. And we're going to try and relate them back to corn because I think that gives us a good perspective on both crops. So to kick it off here, I love showing the soybean yield trend graph, and everybody always likes to see it. Obviously, this is a product of genetics and management and the environment that we've all been a part of. And what this line really represents is our soybean yield gain over the last approximately 50-plus, or excuse me, about 45 years from 1970. And I chose this is when soybeans became a part of Pioneer's business, and we started a soybean breeding program. But as we can see, if we draw a linear line through this, we're right now at about a 0.4 of a bushel annual yield gain, all the way back to 1970. But I think we can all appreciate the last 14 through 17, and then especially in 18, some of the phenomenal yields we've been having from a national standpoint. And I always get the question about, well, why can't soybeans keep up with corn? Why is corn always at such a stronger pace of genetic gain or just overall yield gain? And I always question that a little bit, and I remind folks that, yeah, corn is perfectly linear line of 2 bushels approximately a year that we're seeing a gain in corn, soybeans about 0.4. But what's uniquely happened, especially with the last 5 years of soybean production, is if I draw a different line through this graph, I actually get a better fit. And this line would be a quadratic line, and what it's telling us is that soybean yields are getting exponentially better every year we grow them. So while corn is maintaining a linear line of yield gain, soybeans are actually exponentially increasing. And so I like to start off the presentation with that be optimistic. There's a lot more coming in soybeans, and we're really starting to treat this crop with a higher level of management, and that's being reflected in our national yield gains. Another thing I'd put on this is kind of ask, well, where is North Dakota and South Dakota and Minnesota fit into this picture, and pretty well, actually. Now, what we have to remember is that some might say, well, this is, just a product of really good weather over the last couple of years. But that's not the case, because if we were to look at just irrigated trendline yields, we notice that they're completely flat. Soybean yield in irrigated environments, where we would think longer growing season, higher temps, all that would benefit it to a greater extent, it's actually not the case. Another thing is we're obviously growing soybean production into more of the fringe areas of the country, and yet we're still seeing this exponentially greater yield gain in soybeans. So let's all be optimistic. Soybeans are really taking the spot in corn in terms of genetic gain and gain that we're coupling with management. So that's what we're going to cover today, is really that management portion. Two things that I always tell every grower when we're talking about what can I do on my farm to increase soybean yields, what are some areas that I should focus in. And there's obviously a lot of talk, a lot of products in the market. With Twitter now, we see everything new and great, but I remind them these are two questions that you should be asking yourself from a management standpoint of any practice or any decision you're going to make on your farm in concerning soybean yields. Number one, more canopy, the earlier the better, period. Any way that you can achieve that is a benefit to soybean yield gain. The second one is maximizing the duration of reproductive growth. So once you see the flowers, if we can lengthen the time from the first flower to when the soybean plants are mature, that is a net positive for soybean yield. And I just put this little graph here, obviously yield on the y-axis, and then you can think of this SITBAR term as just sunlight, total sunlight. And we see a very linear, straight-up line. The more sunlight we capture, the more yield goes up. Now, this line is over multiple years, and some years the slope's less, some years the slope is more, but it's always a positive response. More sunlight, higher yields. And we can all probably think of some key factors that would affect that. Number one being planting date, row spacing, seeding rate, variety selection. And we're going to talk through those just of how they affect it and what the extent of that effect is. So when we look at all these different factors, we can model various factors. So along the line here, we have soybean yield on the y-axis, and then we have this blue line with all these dots, right? If the dot is above the line, that's a net benefit to soybean yield. If the blue dot is below the line, that's a negative to soybean yield. So we have a couple questions here where we ask the question, okay, if I was to increase soil organic carbon, would that positively or negatively affect soybean yields? It's neutral. If I was to add more nitrogen, positive or negative, it's neutral. More water. This one is really surprising because you'd always think, boy, more water is always better, but not always the case, and I think we can all relate to that. Those, especially in the prairie pothole region of South Dakota up through North Dakota into the Red River Valley, know that water is not always the best. Faster root growth, actually not a very big effect, but here we get to the blue. Here are some big effects, right? More radiation, more sunlight, greater radiation use efficiency. So what are we doing to the plant to allow it to effectively use the sunlight that it's capturing? Another dot, longer maturity groups. That's a big positive. We'll certainly talk about that and pushing the bounds there. The one big negative is higher temperatures. And again, a point of optimism for all of us in the north is we're really benefiting, right? The folks in the south with increasing temperatures, they're getting a little too hot for soybean production, being a C3 crop. Where us in the north, we're kind of coming into a sweet spot right now for soybean production. I'll pause right there, and there was one good question that was submitted online here about the canopy and being the largest contributor to white mold. And so I'll just take a break and talk about white mold a little bit. Obviously, when we get into reproductive stages and we start to see flowers coming, more canopy is certainly going to be more conducive for white mold, and that's spreading throughout the canopy. However, I would caution us that, fear of white mold, we have management practices that we can use to effectively manage white mold other than trying to reduce the canopy size, right? We can use row spacing, early planting to still achieve canopy with that we need, but not make such a dense canopy. Another one would be, we have obviously approach fungicide that we can use to effectively manage white mold. So I would encourage us, don't get so bogged down on trying to plan for something that might not be there. And we certainly have management practices that we can implement late season for white mold. So another question was on nitrogen. How does nitrogen positively affect soybean yields? And we know that soybeans fix nitrogen. That's one of the great benefits of the crop, but they're also high in protein, so the demand for nitrogen is extremely high. Why then wouldn't we see consistent responses to nitrogen applications? And that one has a couple effects here. So obviously nitrogen goes to the soil. If, say, you put urea out, it'll break down. By the end of the day, it's going to be nitrate. Nitrate stops the fixation process, biological fixation, so you're at really not a net gain. It's not a 1 + 1 = 2. It's really 1 + 1 = 1 type of a situation. And I would encourage growers that, when they're thinking about nitrogen effectiveness, nitrogen is going to be a positive for their soybean yields. Remember that by the time you see a flower in a soybean crop, so at R1, roughly late June, early July, the soybean plant has only accumulated 5, 6, 7% of its total season-long end demand. So any nitrogen up front really isn't hitting the time when the plant's peak end demand is. Then once we move past R1, the demand for nitrogen goes way up. We need a lot of it. The problem is, though, is that actually as we increase yields, as the yield level goes up, the soybean plant places a greater demand on fixation, and fixation contributing to that end demand. So if we think yields are going up, we put nitrogen on, we suppress fixation, we're actually probably in an extent hurting the plant's ability to reach higher yields. So what I always try and encourage people is don't put all your money and energy trying to figure out when's that right time and how much nitrogen should I put on. We should be focused on bigger nuggets. For every 1% of organic matter you have in your soil, you're roughly mineralizing 30 pounds of N. So if you're in a 3% organic matter soil, you're already fixing, or you're already mineralizing, roughly 100 pounds. You add that to what the plant can fix, and soybean plants can fix almost 300 pounds. We rarely get into situations where nitrogen is a limiting factor. Great questions, everybody. I do appreciate them. So if we go back to this chart, that would be why nitrogen isn't a positive or a negative to soybean yields. If we look further and look, okay, more light interception, we got to get more light interception. Why the planting date response? And with soybeans, there's really not a more consistently positive response to a management practice than planting data. It's just so consistent. You can count on it every year, especially as we move into the northern corn belt and west. And there's a lot of reasons why, but I'll use this graph to help hopefully demonstrate that. On the y-axis are, day length, how many hours during the day, and then we have our calendar on the x-axis. These lines are different latitudes. Most of our growers fall in this, 40 to 50 degree latitude area. And when we plant early, let's say we do roughly a May 1st planting date, right? We're going to flower June 21st about, or even if we look at 2018, we saw a lot of flowers coming even earlier than that because we got much earlier planting dates. So again, earlier planting date, earlier flowering, positive effect on yield. So May 1st, here would be lines of approximately the length and duration of reproductive growth. As we can see, we are better capturing the peak day length where the sun's out the longest, and we have a pretty long reproductive window. If we then move to a June 1st planting date, we see that we not only delay flowering to past the peak days of sunlight, but we also shorten the duration of reproductive growth. So delayed planting really has a dual negative effect on soybean yield. Another one, looking at at planting dates. And one of the first questions I'll always ask a grower when they say, well, I just never get a planting date response in my farm. I don't see it consistently. I've done the trials. It's just not there. And the first question that I'll always ask them is, well, what maturity group bean were you using on your farm? And I'll use these couple graphs here to help demonstrate it. This chart right here is relative yield on the y-axis, and then we have just calendar day of the year planting date. So roughly May 1st is where it starts, which would be an awesome planting date for everybody on the call. We see this black box right here. This is 95% of the maximum yield that you can achieve with a 1.5 maturity group bean. Is all in this black box. It extends from just before May 1st all the way past June 1st. So yeah, if you use a really early maturity group, you're likely not going to see the planting date response. There's a synergistic effect here. Now, if I compare this with a 2.5 maturity group, you see we're up to 1.0, so we're maximizing yield. And if I were to draw a box for 95% of maximum yield, you would see after May 1st, we really only have about 10 days until we start to see a statistically significant yield decline. So not only do I encourage you to push that maturity group a little bit further, to further, I should rephrase that, push the maturity group longer, get outside of your comfort zone a little bit. That will allow you to see big benefits in a planting date response. Roughly 0.4 bushels per acre per day is what we find for every day you delay planting past May 10th. So as you can see with this line, there's a big drop-off once you start getting past the second week of May for these latitudes. In addition to that, we've also found that our newer genetics are more responsive to planting date. So the A-series soybeans that you're planting today compared to the varieties you were planting 10, 15, 20 years ago, our current varieties are much more responsive to earlier planting. Another little tidbit I'd throw on there is just a little bit on harvest moisture, right? I know a lot of times we get so rushed at harvest and it's a tight schedule and Mother Nature, and we think, boy, if I can just get some beans that I can get out of the field early, you know, it'll set me up for a good fall of harvest, maybe get some tillage done, all those factors. But many times what ends up happening is we plant an earlier maturity group, we get delayed by weather, and we're then harvesting 10%, 9% beans, especially in those arid climates. And we'll see if you were to harvest a soybean crop at 13% moisture versus 10% moisture, you'd be about a 7 bushel difference. So any time, I know it might delay you a little bit, but if you look at a value of delayed time, 7 bushels an acre is pretty significant ROI for just planting a little bit longer maturity group, pushing your planting date earlier. It really helps things on both sides of the growing season. So with that in mind, I guess I'd flip the page a little bit here and let's talk about the Encirca Soybean VRS tool. It's really the first soybean variable rate seeding tool to the market, backed by pretty robust science. So we're really excited about this tool. I was able to be a part of the development, and really the two key objectives that we wanted to achieve with this goal is to allow growers to better manage their annual soybean seed investment for increased yield and profitability. But then the second part is just as important, and that's the ability to achieve more consistent product performance and actually reduce grower risk. And obviously in our current farm economy and moving forward, risk is just as important as overall profitability on the farm. So here's a little bit of background on it. We actually collaborated with multiple universities from South Dakota, North Dakota, Minnesota, Wisconsin, Iowa, Missouri, Illinois, Indiana, Ohio, every major soybean producing region of the U.S., and then actually up into Ontario, Canada was a part of this. And that allowed us to align with university extension specialists on the soybean seeding rate strategy. We collected over 21,000 data points across 10 years, so very robust, actually the biggest soybean seeding rate data set that's been put together to date. What we found, and I think most of us anecdotally probably we're moving down this path, but we found that soybean variable rate seeding script should be the inverse of corn, meaning that in areas of lower productivity, we should actually increase the seeding rate for soybeans, and then in areas of higher productivity, we should slightly decrease seeding rates. Another very key finding that we had was that the increase in seeding rate in those poor areas should be exponentially greater than the decrease in highly productive areas. Another one we always talk about when we think about soybean seeding rates in this slide is you know, how low can we push them? If anybody on the phone's been on Ag Twitter the last 12 months, you see nothing but talk about lower soybean seeding rates. And you know, this study allowed us to really address that. And what we found is that as you start to push soybean seeding rates lower, your risk substantially increases. And it substantially increases in those high-yielding areas. So the flattest, blackest part of your field, the most highly productive, as you bring seeding rates too low, your risk goes way up. And if I were to put some numbers to that, we've determined over multiple studies in this one that at harvest, in those highly productive areas, you need at least 100,000 plants per acre at harvest. To achieve that, the lowest your seeding rate should be are in that 135,000 seeding rate standpoint on the best, most highly productive areas of the field. If you go lower than that, I'll draw your attention to this graph and that 16% number you see. As you bring seeding rates lower in those highly productive areas, if you go too far, you only have a 16% chance of maintaining the same level of yield as if you stayed at 135,000. So if you're at 135,000 and you decrease by 20% down to say 110,000, you've only got a 16% chance of maintaining that same yield level. That cliff is so steep and so sharp in these highly productive areas. If I move on to the model, this just allows a little bit of a graphical representation. And again, I will reference the term many times, agronomically optimal seeding rate, AOSR. That's what I mean when I'm talking in those terms. AOSR means agronomically optimal seeding rate. On this graph, soybean seeding rates on the y-axis, relative field productivity is on the x-axis. The beauty with Encirca, with Pioneer, is that we have the most highly defined and granular definition of soil types and productivity across the country compared to anybody else, you know, in this space, even the U.S. government. So we're able to leverage that technology to better position soybean seeding rates across the landscape. You'll see in this line that there's really two different slopes, right? If you were to look at the blue line, this would be the local standard seeding rate, maybe 140,000, 150,000 you'd enter there. As we move into areas of lower productivity, again, the seeding rate needs to increase dramatically. But as you move into areas of higher productivity, the seeding rate can come down, but that decrease needs to be much less and much slower. Again, because the risk of yield loss is that much higher when you move into highly productive ground. Moving that seeding rate too low is a dangerous topic, dangerous place to be. Here's just a quick little example of what you could expect with Encirca Soybean VRS script. I give one on the left. This is first without any yield data behind it. And what you can see is, if you can see, I apologize, these numbers in the background are the relative productivity of that soil type, of that decision zone. And you can see as we move into areas of higher productivity, 0.739, the seeding rate goes down. As we move into areas of lower productivity, 0.525, the seeding rate goes up. The same thing is seen then on the graph to the right, except this graph has yield data behind it, allowing for a much more, I'd say granular and precise variable rate seeding script using not only Encirca decision zones, but also the yield data that you're pulling off your combine. So when I conclude about this soybean VRS tool, I again would like to emphasize that we're the first to the market with this. I see this as a really good opportunity, and especially in years with tighter margins, the current state we are, the situation with China. This is a tool that you can use to very precisely manage your soybean seed investment. And what you'll find many times is that your whole farm or whole field average seeding rate will stay roughly the same as what you were doing before. So if you were originally planting 150,000 seeds per acre across the whole field, what you'll find now with the VRS script is that'll still be roughly your average seeding rate, but now the seed is just distributed in a more concise fashion to not only increase productivity, but also increase stability of yields across the field. With that, then I'll move on to the fungicide decision. I think this is always a topic that we talk about every year, even though fungicides have been around for quite a while, and it always draws a lot of discussion because it's an in-season thing. What's the yield level going to be like? What kind of environment are we going to have? Are we going to develop diseases? All of those factors. And I certainly encourage you to, if you need to, take an IPM approach, but the benefits of a fungicide to soybean productivity are pretty staggering and pretty consistent. And I'll go into why we see these very consistent fungicide responses in situations where we maybe see a lack of disease presence. But first, any fungicide decision that we make, I think timing is so key. I don't think I know timing is so key. And many times we'll go out and apply a fungicide a little early because maybe we can tank mix it with a shot of Roundup. We have some water hemp escaping. That's the worst thing we can do with a investment in a fungicide is apply it at the wrong time. R3 is the goal, but I would much rather see you make that application after R3 than before R3. And that's really just due to the amount of biomass that's there in the plant that we're trying to protect to increase sunlight interception, the photosynthetic engine that a soybean plant is. I always like to ask, groups this when I'm in person, but I always challenge them, where do you think the biggest fungicide responses are? Are they in the southern U.S. where it's always humid, they have a longer growing season, always have warmer temps, or do you think it's in the north where it's shorter growing season, we're not as hot, rainfall is less, we're not irrigated as frequently, and everybody usually raises their hand and says, oh, it's got to be the south, that's where it's the most consistent. But actually, we've been a part of quite a few nationwide fungicide studies, and we always find more consistent and bigger responses in the northern U.S., and that's back to the sunlight piece where if we can intercept more sunlight and efficiently use that sunlight, the better off we are. So I'll show you two graphs here real quick. On the y-axis, just dry matter accumulation. On the x-axis is growth stages, days throughout the growing season. If you focus on the graph to the left, what you'll find is you see this dark blue, the darkest blue blob there, that's leaf area. And in lower yield levels, which is represented by the graph on the left, we see at about R5, leaves start to disappear. That blue blob goes down, it gets much, much smaller. And that's because we're losing the photosynthetic engine, leaves are dying, they're senescing, they're falling off. If we go over to the right graph, we're in a much higher yielding environment, we're using fungicides. Look what happens with this blue blob. This represents leaf biomass. When we get to R5, R6, that blue leaf line, the very top line, it's flat. It doesn't start to fall off until almost R7. So we have a much longer duration of canopy growth, and maintaining that canopy for, again, increased photosynthesis because we're intercepting more light. And that's so critical in the northern U.S. because that's our biggest limitation to soybean yield right now is sunlight. There's not a bigger limitation that we face. Another one besides, just the ability to continue to intercept light is we all know that the seed's demand for nitrogen is very high. They're high protein. That's what we grow soybeans for is, well, protein and oil, but protein being a big piece there. And if you remember before, when we were talking about nitrogen, I said, well, the biggest source when we're increasing yields is through fixation. The next biggest source is remobilization, or nitrogen coming from the plant and moving through, from the leaf to the petiole, the stems, up through the pod to the seed. That path there, it's such a big contributor. And so again, this big blue blob that's circled in green, that's leaf nitrogen. It's not dry matter, it's nitrogen physically in the leaves. And at the end of the growing season, all the nitrogen protein that's in that soybean seed per acre, 23% of it comes from the leaves. So not only is it important to maintain the leaves for photosynthetic reasons, but also because it's the most valuable source of nitrogen that we have on the plant. If you get to R4, R5, and you start to drop leaves off the ground, they start senescing, that's basically wasted energy. The plant had to expand energy, fix nitrogen, transport it to the leaf, to then just let it fall right to the ground. It was a waste. So if we can maintain that leaf and in turn remobilize and send that nitrogen to the seed, that's a net benefit. The next one I would just bring up real briefly is rotation, and especially some growers as we're moving into the West, where we have the ability to use more diverse crop rotations. Alfalfa, we grow some wheat sometimes. If you go really west, obviously then we get into the flowers. Canola starts to show up a little bit. And so what the next couple things I mentioned is just the rotation effect and a free way that we can substantially increase soybean yields. Many times we think of the rotation effect, or soybeans as a product of pest disease cycles, nutrient imbalances, less organic matter. Nobody's really dialed it in very much. But what we do know is that after the second year of soybeans following soybeans, you really find this bottom of soybean yield, and it's substantially lower than a corn-soybean rotation. That's not new, but the question is, well, why do we see that? Why do we see that rotation effect of rotating away from soybeans to corn or another crop and then back to soybeans? Why do we get that bump? And nobody's really been able to explain that very well until now. And I'll just highlight a little bit of work we've done, and don't get too caught up in the axes of this graph, but what I draw your attention to is the brown blob here. It says CC. That'd be continuous corn. And what these brown and green blobs are representing are the microbial community in the soil, right? So not necessarily diseases, but think of the microbiome. That's a hot word, but all the beneficial bacteria and fungi that are in and surrounding the root throughout the growing season. We can quantify what that community looks like. Does that community look like Brookings, South Dakota? Does that community look like Los Angeles, California, right? Two similar, two very distinct populations. And what we'll find is that a corn on corn versus a soybean following soybean, they're drastically different, right? The blobs are very far apart. And that's something that we can exploit with rotation. Now, if I move on to looking at, well, what is the yield effect then? If we know that certain bacterial communities and microbial communities like corn better than they like soybeans, what does that do from a management standpoint for us as the grower? And what we can see is that when we move to the less diverse side, so if we move left on this x-axis, soybean yield goes down. As we move left, that's less diversity. So this would be a community of soybeans following soybeans following soybeans following soybeans. As we move to more diversity to the right, soybean yield goes up. So this would be a much more diverse community. So say soybeans, then wheat, then corn, then alfalfa for a couple of years, then maybe wheat, corn, soybeans again, right? We have a much greater positive rotation effect for soybeans in those situations. And this is all due to the diversity that we develop in the soil. This is probably one of the biggest benefits I see from cover crops currently coming onto the market, and how, we always are asking questions, well, what's the economic benefit of cover crops? How can we effectively use them? I see this as an opportunity. As we get a cover crop planted, we can hopefully shift the bacterial community in the soil shifted away from soybeans one more time before we go back to soybeans. So you could think of it as not corn, soybeans, you could think of it as soybeans, cover crop, corn, cover crop, soybeans, and we effectively add different crop rotations into that system, therefore shifting the bacterial community to make it more diverse, more productive in layman's terms. Keeping on to the soil side of it, I just would really bring up a quick point about fertility and specifically potassium. I think that's probably the biggest nutrient we've lost touch with in soybean production throughout the country. We spend a lot of time on nitrogen and micros and all of those other, what I'll say are more fun and sexy nutrients to work with. And the biggest player, potassium, is usually left in the dust. So I'd remind you that 2.3 pounds per bushel of potassium is taken up by the plant. Then 1.17, roughly 1.2 pounds, is removed at harvest with the grain, meaning 50% of all the potassium taken up by the crop stays in the stover. At a 60 bushel crop, that's 75 pounds of K2O, that's the fertilizer equivalent potassium, in the stover. K is a soluble nutrient, so it's not like when that stover goes back to the, you blow it out the back of the combine, it hits the ground, you till it under. It doesn't have to go through a cycling process or mineralize. It's a soluble nutrient, meaning that, bam, right when it goes in the soil, it acts just like fertilizer does, and it's available to the crop. I bring this up because too many times we drive down the highway in the fall, and what do we see? We see paths we can pick out right where the combine drove. We see the swath. It's laying, and, the head was 45 foot, and the stover behind it is spread about 25 feet. And at 75 pounds an acre of potassium in that stover, your combine not only is a combine, but it's a fertilizer spreader at the same time, especially for potassium. So I really encourage growers, especially as equipment's getting bigger, we're covering more acres, weather's a bit more extreme, we're trying to cover acres in a shorter, less days, shorter amount of time. There's a couple things we can do. Number one, you can't control the wind, but you can control your combining direction. You can control your starting point. Too many times we pull in the same field approach, the head goes down, we start along the fence line, move across the field. So in light of this, and especially with variable rate fertility and us trying to understand the variability of potassium throughout the field, if you're not going to appropriately manage the stover, it really makes variable rate fertility hard to utilize and to effectively utilize if we're not, again, optimizing the spread of stover and making sure we're doing it as evenly as possible. So I encourage you just to keep that little tidbit in your head as you're combining. It's something that I really like to follow pretty religiously. With that, those are the management suggestions that I'll share with you tonight. I have a couple questions I'll answer here in a minute, but I would like to highlight our Encirca Pro app and some of the new functionality that we have with that, because I think it is so important. And there's a lot of things that the combine picks up and yield monitor that it can't explain or can't even pick up. And many times when we're making management decisions and changes on our farm, having another tool to evaluate that is certainly to our advantage. So within Encirca Pro going into 2019, we still have the same world-class imagery working with Planet Labs, very frequent, detailed maps of not only crop health, but just aerial imagery, so you can get a bird's eye view of what the crop looks like. In addition to that, you can now add your yield maps on top of that, so you can compare side to side. That is obviously very beneficial. I know we can all think of a lot of good reasons that could help out in our operations. But also we added not only seeding rate maps, but hybrid and variety placement maps. again, allowing us a more detailed and granular view to try and understand different outcomes on our farm. And the beauty of it is you want to compare them, you want to overlay them, and with Encirca Pro you can do that. You can look at different maps side by side, whether that's the yield map versus the seeding rate map, the crop health image versus a yield map or a seeding rate map. Again, our combines are getting better. We can more accurately look at yield, and again, a yield monitor is just relative yield throughout the field. It's not really the final number. It's just distributing yield accurately throughout the field. But again, that yield monitor can't always pick out everything, and having multiple other tools and resources at your disposal will only help you learn more about the management practices that you're implementing on your farm. Because as you've heard probably many people say, if we're not trying something new and evaluating new technology and new practice every year, we're falling behind. So Encirca Pro allows us the ability to, again, to evaluate those management practices in great detail. So a couple take-home messages. You know, this is a decade of the soybeans. We're outpacing corn right now. That's really exciting for someone who works a lot in soybeans. Again, I'll remind you the 2 questions you should be asking on your farm before you implement any changes in management for soybeans. And that's the first one: are we increasing the amount of light we're intercepting throughout the growing season? And number 2, is this going to extend the duration of reproductive growth? R1 flowering all the way up to maturity. These management practices that we talked about today provide long-term and more resilient gains. I always encourage people to remember that high yields are not a one-year phenomenon. They're many times the product of a system and not just a one-year change. And we've actually done quite a bit of work in this area. We published a paper on it showing that high-yield corn management and high-yield soybean management, along with high-yield wheat management, they synergistically help each other. So even for guys that are chasing high corn yields, your corn yields are going to be that much better if you have a high soybean yield. It's the product of a system, not any one particular crop and or management practice. Number 2, in addition, Encirca Pro it's a good tool to help us monitor the crop, evaluate changes in management, and uncover benefits that the combine can't always pick up. And I started with an optimistic note, and I'd like to end on an optimistic note. You know, we see this G by M by E, G by E by M, genetics, management, environment. That formula equals yield. That's what we see across our field on our farm. Technology really sums up genetics and management. That's what we can do, right? That's what we have to do to exploit the E, the environment that we're given. Many times I always give breeders a good kick at this, and they always think they're just responsible for all the yield increases that have happened across the Midwest over the last 40 years. But in actuality, if we were to divide the G and the M out, it's almost split. That yield increase that we've seen since 1970, roughly 50% of it is due to genetics. So that's advancements in breeding, A-series soybeans, all that. But the other 50% is due to management, high-level management. And that's where we come in as farmers. Obviously, we have to pick the right genetics and the right varieties, but largely we leave that up to breeders and Pioneer, and that's our charge, is to bring you high-yielding genetics that you can use and complement the management that you're using on your farm. And we've given a couple examples of that where G by M is a synergistic relationship. So, again, if you look at this graph, this is over the last 30 years. What's the yield gain per bushel, per acre, per year, according to the change in the climate, or the weather variability, I'll call it. So compared to 1990 climate and what today's climate is, it's helped Minnesota, Wisconsin, and South Dakota to this extent every year. If you look at the bulk of the Midwest, not very favorable. Any North Dakota growers on the line, you're almost to zero. You're at a negative, but I think a lot of that, again, is pushing to some of those fringe acres. So again, high note, be positive. In the north, we have the biggest opportunity and potential to continue to increase soybean yields with genetics and management. we're sitting in the best spot. If someone was going to ask you, where do you want to go buy some land and start farming so that you can increase yields at the fastest rate, I would tell them, go to the Northern Corn Belt. That's where you want to be. And with that, there have been a lot of really good questions that have come in, everybody. So I'm gonna take a stab at a couple of these and start asking. Please type in any more. But the first question that came in that I saw was about back to our soybean VRS. They asked, is it variety specific? And no, it currently is not in the system variety specific. Those are attributes we're working to put into the model right now. We have a good idea of what variety attributes would affect a soybean VRS script. So stay tuned. That's yet to come. But currently, the tool is not variety specific. Next one: if I need to plant beans later than my normal planting date, should I still use variable rate seeding management? 100% yes. The effectiveness will probably actually go up as you delay planting because, again, sunlight interception is what is driving the variable rate seeding tool. And as we move later into the growing season, our chance to capture more sunlight is just that much more limited. It's now June 1st, not May 1st. And so the usefulness of the tool is just as great, if not even greater. Another thing I would maybe throw out there for, the VRS seeding rate and later planting is you'll want to obviously increase seeding rates as you delay planting, maybe May 1st into June. 20% increase in your seeding rate is certainly where you want to be. I would not do an increase any less than that. In addition to increasing seeding rates, narrowing up your row spacing is another very good investment. So whether you have to custom hire, have the neighbor help you out, or even double plant your beans, so plant them one way, square with the field at 100,000, then come back and at a slight angle plant in another 70,000. While that might seem crazy, and I always get weird looks for it, it's a very good investment. If you look at custom rates, $20 an acre to plant soybeans, well, right now that's 2.5 bushels. Hopefully that turns into only 2 bushels here before too long. That is well worth the investment to go narrow rows, especially in a replant situation. Here's another great question on what level of phosphorus do you like to see on high yield beans? Breyer, Olson, tests in parts per million, and that's a really good question, and I'll answer that maybe both for phosphorus and potassium. Fertility is very much a risk game too, and specifically for phosphorus, we'll start there. I like to see in Lake County, where we're farming at, our goal is to have our P levels in the 25 to 30 range. All right. Do we get a response every time over 20? No. But the variability in the risk substantially goes down when you get over 25. So again, on owned ground that's in your family, you're going to be farming for a long time, very much worth the investment to get over that 25 ppm mark to decrease the variability in your yield response, or in other words, increase the consistency of maximizing production. For potassium, that number is 200 parts per million, again, for all of the same reasons about consistency in yield performance and reducing variability. In tough white mold prone areas, how low of a population are you comfortable with going? 75,000? We have seen 10 to 20 bushel hits due to white mold. Yeah, so with white mold, that is always, as I was getting to earlier, you don't know if you're going to have it. Don't start changing high yield management based on what you think is going to happen. I've done a lot of work in southern Wisconsin, which would be unfortunately dubbed the white mold capital of the country. And actually what we see is, of the two big management factors that you can probably think of, is planting date, seeding rate, row spacing, and variety selection. Variety selection is number one. There's not a better management practice you can do for white mold than variety selection. Next after that, I would encourage you to plant early in wide rows. So widen out the row spacing if you're in some really heavy white mold areas. And then on a seeding rate perspective, no, I would not go down to 75,000, because at that point you already know you're giving up yield. You're starting off the season already sacrificing. And I know the response would be, well, I'd rather give up 10 bushels than 20 bushels. And while I hear that, whether you plant 75,000 or 130,000, that's not going to be the incidence difference in white mold. If you're going to get white mold at 75,000, you're going to get it at 130,000 or vice versa, right? So at that point, I tell growers, focus on variety selection, number one, widening out the rows, and very detailed scouting to understand when you need to make that application of a fungicide to control white mold. Hitting the fungicide window, that first one at R1 for white mold, is so key and very effective at managing the disease. In terms of frost risk, which is worse, early planting or late harvest? In my time, I haven't seen beans that needed replanting due to frost. I have seen beans ruined with early frost in September. I would agree with that comment 100%. I think we are way too sensitive to early planting soybeans. Actually, believe it or not, soybeans are very resilient to frost. Planting them early, I never use temperature as a big gauge. I always look at how fit the soil is. Are we temperatures rising in the soil? Because we got to remember, if say we get them planted in May 5th, we get down to 30 degrees, we get a little frost that comes in, or 28 degrees. The soil has absorbed a lot of heat from that point, and it'll actually heat the top couple inches of air above the soil, kind of buffering the impact of the frost. In addition, the cotyledons, basically when the seed comes out and the big bulbs, what was the seed, they're full of salt, right? So that makes them pretty tolerant to frost, and they surround the growing point. If you singe off a cotyledon, that's no problem because the growing point is still intact. What crop do we plant first, corn or soybeans? That is a really good question. If we were to look at all the seeding rate, planting date data for corn and soybeans, what you would find is you would find more consistent positive responses to soybean planting date than you do for corn. And this is again due to a physiology standpoint, right? Soybeans are trying to intercept as much light as possible. Corn yield increases over the last 30 years have largely come from our ability to make bigger kernels, right? That's Pioneer's corn breeding program, right? If you were to ask a grower, what's your ideal plant, right? We're like a brown husk and a green plant. And that's where yield increases have come for all hybrids, all companies over the last 20 years, is from greater grain fill. Not from earlier planting so that you can set more kernels, more round, more deep. It's from better grain fill. So what that's done is it's somewhat made the planting date response in corn a little more elastic. But for soybeans, it's very consistent and consistently there. So what I encourage a lot of growers to do is, if you do have two planters, obviously start one on corn, one on beans. The next one, if you have one planter, plant the field that's fit. I know it's, we always get in a pain about switching over from corn to soybeans, but in my opinion, these planters, they switch over so easy now, right? New plates, change the depth, hit a couple buttons in the monitor, go plant the field that's fit, whether it's corn or soybeans. Also, another thing I'd put out there is, while I do encourage the use of the VRS tool with Pioneer for better and more consistent product performance, if you can find a nice deal with a used planter, that we know soybeans don't have to be ideally placed like corn does, why not go pick up another planter for substantially lower cost. Doesn't have to be the fanciest thing, but allow you to plant, and obviously you need the manpower, but plant corn and beans both at the same time. So long story there, but I would be planting both at the same time, and I would encourage everybody, just go out and plant a soybean field early. I think you'll be really surprised on what kind of response you'll get at that field. How early is too early to plant, or where is the cutoff temp date to reach max yield? I won the soybean yield contest in Wisconsin a couple years in a row when I was in grad school with 105, 102 bushel yields, and I was always planting April 20th, and that latitude is roughly the same latitude as like Sioux Falls, South Dakota. So again, it's not a date. I won't focus on the calendar as much as I would focus on is the soil fit. Is the soil fit? Is the soil temp rising? Get out, get it planted. We honestly have a lot more problems when we wait to plant and the soil gets too dry. That's a much bigger problem than planting earlier and potentially getting a frost. 25 parts per million, was that in Bray or Olson? And that's a very good call out. When I was talking about soil test P and K levels, I was talking in Bray, not Olson. So that's a very big distinction there. How about IDC and plant population? Would I step it up if I have IDC tendency? This is a good one for the Red River Valley, western Minnesota, even into eastern South Dakota, where IDC is a perennial problem. One of the best management practices, besides variety selection for IDC, is increasing the seeding rate. That will do wonders in reducing the severity of iron deficiency corrosis, and that's one of the great tools that you can use with the variable rate seeding. The variable rate seeding tool that Pioneer has now is when you know where those IDC hotspots are at, make a script in the tool. It will increase seeding rates automatically in those areas, allowing for higher and more consistent production. Yeah, I'm not going to buy a wider row planter. Have 20 inches cheaper to cut. I don't understand one. Here's the next one. Thoughts on rolling. How about after they are up? Rolling soybeans, we very rarely see a true management response to rolling soybeans. This is totally a harvest efficiency standpoint and obviously equipment wear. How about rolling soybeans when they are up? Again, I would certainly be adjusting pops if you're planning on rolling soybeans when they're up. If you're going to roll them when they're up, make sure it's late in the afternoon when they're not as turgid. But no, I would certainly discourage rolling when they're up. That's the only time I've seen negative responses to rolling. We often plant corn on April 15 if soils are fit in western Wisconsin, or excuse me, western Minnesota. Concerns for beans in mid-April planting? No, they're very similar to corn in terms of the temp it involves for germination and the amount of water that needs to be imbibed. They're again very cold tolerant. I would not worry about if the soils are fit and you can move forward. Even if it means sacrificing a little bit in stand, you'll more than make up for that with the earlier planting, increased light interception. Obviously, these are key areas where you need to use a full seed treatment package when you're planting early. Does maturity make that much of a difference? Question. It seems to me that 1.0 yield just as good as 2 3s. Yeah, maturity group is one component of the variety selection and placement process. Obviously, disease scores need to be factored in there, how it fits into your harvest rotation. But no, especially as we move north, we do see a yield advantage from later maturity groups. Now, is that the do-all, say-all? You know, if you plant a really poor white mold scored variety in a white mold hotspot, yeah, that's a bigger factor. But when we're going to maximize yield, planting later maturity groups is certainly a very consistent return for no additional cost, right? Whether you plant a 1.0 or a 2.3 or a 2.0, it's the same dollars spent with the opportunity for increased yields. So I would encourage growers, you know, if you're looking to get outside of your comfort zone a little bit, a very cheap, a zero cost to you, plant earlier with a longer maturity group. Those are two cost-effective ways to very consistently increase soybean yields in the northern Corn Belt.
All right. I see we have 8 o'clock. Are there any more questions?
At this time, there are no other questions in the queue.
Well,
all right.
I'd like to just thank everybody for taking the time tonight to listen about soybean production, and I sure enjoyed it. I hope that I've left you optimistic about the potential for soybean production to continue to increase in the northern Corn Belt. As I said, I farm in eastern South Dakota, and I have nothing but high expectations of where soybean production in the north is going to go over the next decade. So thank you very much.